Today we are going to look at this problem. Its rating is 2100, so it's quite hard. It's also posted by a dash. Alright, so let's begin. As always, we are going to introduce this problem by explaining the example here. So in the input, we have a number here. It indicates the number of lectures we are going to have, right? So in this case, we are going to have 2 lectures. 1, 2, 2 lectures. And the lectures, um, each of the lecture happens in 2 rooms, right? The left part happens in the red room, right? Starts from 1, ends at 2, right? Starts from 1, ends at 2. And the right part happens in the blue room, right? Starts at 3, ends at 6. Starts at 3, ends at 6. So this lecture happens in 2 places, 2 rooms, one in red room and one in blue room, right? Also, for the second lecture, in red room, it starts from 3 and at 4. And in the blue room, starts from 7 and at 8, right? So for these 2 lectures, in the red room, these 2 lectures doesn't have overlap, right? So let's say if one lecture starts from 7 ends at 9, and another one starts at 9 ends at 11. We say at the ninth point, at this time, they are overlapped, right? They have an overlap time point. So for these 2 lecture in the red room, they don't have overlap. And so as the lectures in the blue room, they don't have overlap as well, right? So we output yes here because we output a no only under the condition that we find 2 lectures that overlaps in one room, but not overlap in the other room, right? So to further explain this, let's take a look at the second example, right? So let's erase the input here and mark the lectures in the second example. So in the second example, we have 3 lectures, 1, 2, 3, right? For the first lecture, it starts from 1 ends at 3, right, in the red room. And in the blue room starts from 2, ends at 4. And so as the lecture 2 and the lecture 3, right? So for the lecture 2 and the lecture 3, we can see that in the red room, they have overlap, right, at time 4. But in the blue room, they don't have overlap, right? So this pair satisfy that condition that it overlaps in one room and not overlap in another. So we output no in this case, right? So this is the meaning of this problem. So how do we solve it? So the first step is to find the overlays in red room, right? So let's remove the blue lectures for now, right? So we only have red lectures for now. So how do we find the overlaps in the red room. So we can use scan line here, right? So scan line means you have a invisible line here, and you move the line to the right, right? And see the collision of the line with the lectures. So this line starts from 1, right? And it collide with the starting point of the first lecture, right? So we put the first lecture into a set here. So we keep a set here, right? And uh, we put the first starting point into the set. And then we move the line to the right. And so at this point, there is no starting point and ending point at this time, right? So we keep moving to the right, right? So we end up here. At this point, we collide with a starting point and a ending point, right? So we begin at the starting point, which is the third lecture here, right? So we put the third lecture into the set. That means we already find the starting point of lecture 1 and lecture 3 here. And then we move on to the ending point of the first lecture. So we got this ending point. At this point, all of the points, all of the lectures that in this set are the overlay lectures, right? So this guy overlay with 3, lecture 3 here. So at this point, we find a overlay, right? We find out that one overlay with 3. And because it is the ending lecture, ending point of lecture 1, so before we move on to the next time point, we remove the first lecture from the set, right? Um, and then we move on. We move on to this point, move the line, scan line to this point, and we find another ending point and another starting point here. So as always, we are going to begin with the starting point, right? So we put a lecture 2 into the set. And we find out there is an ending point of lecture 3 here. So at this point, we can know that lecture 3 is overlaps with all the lectures inside this set, which is lecture 2, right? So lecture uh, lecture 2 overlaps with the lecture 3, right? And because we find out the ending point of lecture 3, so before we move the scan line further to the right, we remove lecture 3 here, right? And we move the scan line to the right, which is here. And then we find the ending point of lecture 2. So we remove it from the set and we reach the end. So the whole process stops, right? So during this process, we find two overlays, 1 and 3, and 2 and 3, right? So let's start from the 1 and 3, right? So we got this lecture and this lecture, we find out they are overlaid. So the next step is to check if lecture 1 and lecture 3 are also overlaid in blue, right? Because if we overlay in one room, the other room should not be overlaid, right? So how do we make sure that they don't have overlay in another room? So be careful here because there might be multiple lectures has overlay, right? For example, excuse me. Um, here is another input, right? So the only number changes is here. So we change we change the second input, change this value 4 into 3, right? So we just change this guy, change the length of this guy, right? So in this case, the um, three lectures are overlaid at this position, right? So how do we find out this overlay? As we did before, we use scanline from the starting point, and at this point we put lecture 1 into the set, right? And then we move to this point. No starting point and ending point at this position, so we keep moving. So at this point, we find out two starting points. One is lecture 3 and one is lecture 2, right? And we find out ending point of lecture 3. So at this point, we know that 3 is overlay with 1, 2, 3. Actually, 3, we don't count 3 because 3 doesn't overlay with 3, right? Obviously. So lecture 3 overlay with lecture 1 and 2. So which means these 3 lectures are overlaid. So um, so how do we find out these 3 lectures overlay state in the blue room? So let's see how we find it out, right? So first, the overlay, the mass presentation of overlay means if the text in the problem says that if two segments are overlaid, right? If they are overlaps, it means the maximum of the two starts and is less or equal to the minimum of two ends. What does it mean? So let's say we have two segments here, right? So how do we know if they are overlaid? So the left part, maximum of two starts, is this guy, right? Because this guy is bigger than this guy. And minimum of two ends is this guy, right? Because two ends are this guy and this guy. So this guy is smaller than this guy. So it's a minimum of two ends. And this part is the overlay, right? So this formula basically means if there is if there exists length for this part, if the length of this part bigger than 1, bigger than 0, that means these two segments has overlay, right? So if the length here is, let's say the ending point of the first segment is here, and the starting point of the second segment here. This, if we use this guy minus this guy, it will be a minus value, right? It essentially means the overlay part equals to a minus negative value. So this part doesn't exist. So there is no overlay between these two segments, right? So in the same way, let's define the overlay for multiple segments, right? So if we have multiple segments like this one, overlay is this part, right? And the length of the overlay equals to the the minimal of all ends, which is here in this case, right? We have 3 ends here, so we choose the minimal one, and the maximal of all starts, right? Which is here, right? So this guy minus this guy equals to the length of the overlay part, right? If this part is bigger than 0, then we have overlay between these multiple segments, right? So if we can find the multiple segments overlay, it means uh, that each pair of these segments has overlay, right? So let's say this guy and this guy has an overlay, which is here, and this guy and with this guy has an overlay here, right? So each pair of them has an overlay here, and it's essentially means that if this overlay does not exist, that means at least two segments has no overlay, right? So for example, let's say we have 3 lines like this, right? So does these 3 segments have overlay? No, right? Because the maximum of the maximum of all starts is here, and the minimum of all ends is here. So this guy minus this guy is a negative value. So the overlay part is negative. It doesn't exist, right? So at least two of the segments does not overlay. In this case, these two guys has overlay here. These two guys has overlay here, right? But these two guys does not have overlay, right? Okay, so with that being said, we can easily check if the blue parts of these lectures have or not does not have the overlay, right? So we already know the uh, the overlays lectures in the red room. So we find their correspondence in the blue room, right? So let me find it. It's here, right? So for lecture one, it starts from 2 to 4, right? That's 2 to 4, and in lecture 2 is from 6 to 7, right? And so we can remove the red lines and just look at the blue parts, right? Let's take a look at these parts to see if they have overlay or not. So if one of the pairs does not have overlay, that means we are going to output no, right? So can we find 2? Yes, the answer is yes, because this guy and this guy does not have overlay, right? So how can we get the answer very fast? So when we get this two, the way we get these 2 lectures is that we put uh, these 3 lectures into a set, right? So when we put them into the set, we also uh, keep 2 other sets. One is to um, record. One is to record all of the starting points of the blue segments, right? This set is record all the start points, and this set is to record all the ending points of the segments, right? And then we can easily get the minimal value of the ending points from this set, right? And we can easily get the maximum value of those segments starting points from this set, right? And we can compare them. So if the maximum of start points bigger than minimal of all ends, right? Then we can know that there exists at least one pair of blue lectures does not overlay with each other, right? Here is our code, right? So first, we're going to read all those starting point and ending point of those lectures, right? And then this part is to check if there exists a pair of lectures that overlay in the red room and not overlay in the blue room, right? And this part is to check the opposite, which is overlay in the blue room, but not overlay in the red room, right? So these 4 numbers indicates the starting ending point of um, the rooms, right? Um, and this part is we put all of those um, points, starting point and ending point into a sorted array, right? This is the way we implement the scan line, right? Because with scan line, we want to scan from left to right. So we will iterate from the start point of the leftmost start point and to the rightmost ending point, right? And these two sets are the sets we keep track of the starting point and the ending point of the lectures in the blue room, right? So, um, so if we find a ending point, then we are going to actually 0 means the starting point. If we find out a starting point, we are going to put the correspondent lectures in the blue room into the two sets, right? So the starting point of the blue room is inserted into this set, right? And the ending point of the blue room will be inserted into this set, right? And then we will check um, the uh, the maximal value of the starting point uh, is equal is bigger than the minimal value of the ending point, right? So this part is where we remove the starting point and the ending point because we find out a ending point in the red room here, right? Um, and if we find one of the um, checkers satisfy the condition, we output no here, right? So I guess that's it. Thank you for watching. Bye bye.